Hi, this is Dr. John Bergduff. In this video, we're going to explore solving a rational inequality with an alternate approach. Now, the alternate approach is an approach that does not require you to use test numbers or test points. So I hope you'll find it as an interesting alternative. When you see this together with the method that does require test points, you can decide for yourself which one works best for you. Now, this video will be easiest to follow if you first watch my video entitled Solving a Polynomial Inequality, an Alternate Approach, because you will see that the process is very, very similar. And so if you've seen that one first, you will have a much better chance of feeling good about this one. So what is a rational inequality? Well, the word rational comes from the word fraction. So simply, a rational inequality is an inequality that has a fraction in it, but particularly a fraction that contains polynomials, like the one you see in example 1. Now, the process that we're going to follow to solve this inequality has 5 steps, which I'm going to show you. The first step turns out to be really easy for this particular question. Get 0 on one side of the inequality. Guess what? It already has 0 on one side of the inequality. You're done. Step 1's done. My next example will have to work harder. You'll see. Step 2, get one simplified and factored fraction on the non-zero side. So on the other side of the equation, if there's more than one fraction, you need to combine them. But we only have one, so that's good. We've got the one business down. But we need it to be factored. So we look at the polynomial in the denominator in particular, and from what we've seen with factoring before, we realize pretty quickly that that does factor rather nicely. We're looking for two numbers whose product is -5 and whose sum is -4, and a really simple way to do that, x minus 5 times x plus 1. So that's nice and wonderful. Now, in step 3, what we're going to do is take each factor that we had from step 1 and set them greater than 0. Now, in the previous video, you saw the same thing. You might say, why am I looking at greater than 0 when the inequality says less than or equal to? It's kind of arbitrary, but the basic idea is that when something is greater than 0, it's positive. And wherever it is not positive, it must be negative. So when you look at just one of inequality, you kind of get both. So what were my 3 factors again? Well, there was x minus 3, and we set that greater than 0. And then there was x minus 5, and we set that greater than 0. And finally, x plus 1. All of these very easy to solve. On the first one, you add a 3. On the second one, you add a 5. And on the third one, you subtract a 1. Now we create what we call, or what I call at least, a sign chart. And this is very similar to my previous video, so I hope you'll see the similarity. What you do with your sign chart is you take all the factors that you considered in step 3, and you list them one over another. So x minus 3, x minus 5, x plus 1. And then below that, and to the right a little bit, you create a number line. And in your number line, you just want to make sure that you have room for the values you got when you solved these inequalities. So I just want to make sure that I hit a -1, a 3, and a 5. Maybe I'll go like this. I'll go -2, -1, 0, 1, 2, 3, 4, 5, 6. And I'll show you in the next example that you can make it even simpler than that. You can just pick those 3 numbers and make sure you've got them in the right order. Now, below the number line, create the factored form of the inequality that you got in step 2. That would be this one right here. Let's take a look at that. So it would be x minus 3 divided by x minus 5 times x plus 1. Now let's look at each one of the factors individually. And when we say that we solve the inequality x minus 3 is greater than 0, we're really asking ourselves the question, when is x minus 3 positive? And so the results we have are that whenever you pick a value of x that's to the right of 3, that factor is positive. I'm going to indicate that by looking to the right of x minus 3, and for all values greater than 3, I'm just going to put little plus signs. And that indicates that for any of these values of x to the right of 3, the factor x minus 3 will be positive. Now the deal is, if I had solved x minus 3 is less than 0, that would have given me x less than 3. So if everything to the right of 3, every number to the right of 3 makes the factor positive, every number to the left of 3 makes the factor negative. I don't have to really work at that. If it's positive on one side, it will be negative on the other side, and I put a bunch of little negative signs to indicate that. What happens exactly at 3? Well, if I actually plugged in 3 into the inequality x minus 3, I would get 0. So right there at the 3, I'm going to put a 0. I'm going to do the same thing for the other two factors. So the second factor, x minus 5, that's positive whenever x is greater than 5. So for all values of x greater than 5, I'll just put a bunch of little plus signs. And if that's positive to the right of 5, then it must be negative to the left of 5. So I put a bunch of negative signs. Doesn't matter how many, just a bunch of them. And at 5 itself, that factor would be 0. I hope that's making sense because it's just a nice pattern you'll keep following. What about the x plus 1? Well, that's positive whenever x is greater than negative 1. So we'll put little plus signs all the way to the right of negative 1, just like that. And if it's positive to the right of negative 1, it must be negative to the left of negative 1. And at negative 1, it would give me 0. Now, what I do with the fraction below the number line is I think about this. So all the numbers in the interval that is to the left of negative 1, for any value of x in that interval here, the x minus 3 is negative, the x minus 5 is negative, and the x plus 1 is negative. If you take a negative number and divide it by a negative number times another negative number, the total result, final result of all that would be a negative number. So the entire fraction in that interval is negative. I'll put a bunch of negative signs. Now, when I get to negative 1, notice the 0 there, something different happens. Let's see how that works in this fraction here. So at negative 1, looking at the top row, the x minus 3 is negative, and the x minus 5 is negative, but the x plus 1 is 0. Now the x plus 1 is down here in the denominator. So if I have a 0 in the denominator, we know we're not supposed to do that. Division by 0 is undefined. So at negative 1, we have a very interesting situation. This particular fraction is not defined. I'm going to put a little symbol there to represent it's undefined. I think I'll just put a U. U for undefined. Now, consider the piece of the number line between negative 1 and 3 the next time you hit a 0. In this part of the number line, the x minus 3 factor is negative, x minus 5 is negative, but x plus 1 is positive. A negative divided by a negative times a positive would be positive. So I'll put a bunch of plus signs until I get to that next 0 at 3, and you might say, oh, okay, I know, I got to put a U there. You have to pay very close attention to where the 0 occurs. This value of x would give me a 0 in the numerator. Now 0 in the numerator is fine. 0 divided by anything is 0, unless that thing is 0. But here we're taking a 0 divided by a negative number times a positive number. So you don't have a 0 in the denominator. That result will be 0, not undefined. What happens between 3 and 5? Well, again, we look at what happens to each of our factors. In this interval, this factor is positive, this one's negative, and this one's positive. A positive divided by a negative times a positive would be negative. So I put some negative signs until I get to the 5. I have a 0 in one of my factors here, and what I particularly want to notice is that that's going to occur in the denominator. That's a bad thing. A 0 in the denominator makes the fraction undefined. I'll put a U for undefined. Different from a union symbol, which we'll actually see later. Just a regular U, undefined. And you just move down the number line from left to right. When you get to the right of 5, you realize that for values of x over here, you have a positive, a positive, a positive. The positive divided by a positive times a positive is positive. Okay, that's a pretty picture. What do we do with it? Well, there's one more step. In step 5, you pick the intervals and endpoints that make the inequality from step 2 true. To save a little bit of effort, I'm going to go back and write down what we had at the end of step 2. You could scroll back, but let's just write it down. We had this inequality at that point. X minus 3 over x minus 5 times x plus 1. Less than or equal to 0. Less than 0 means negative, or equal to 0. So what you do is you go back to your sign chart and you ask yourself, where are the intervals that you got either a value for a fraction that was either negative, I see some right in here, or 0. That would include this one. So it would be all the numbers between negative infinity and negative 1. Let's go back this way. Looking back, we do not want to include negative 1 because the expression is undefined there. So don't include that. Now, separate and apart from that, you have negative numbers again between 3 and 5. So we're going to put a little union symbol. And we get 0 at 3. So 3 is a good place. We do want to include the 3 because that gives me the 0. But not the 5 because the 5 gives me a value that's undefined. Negative infinity to negative 1, 3 to 5, include the 3, don't include the 5. And if you want to represent, you can leave the answer like this, it's in interval notation, but if you also want to represent this on a number line, you could go back to the number line that we drew in our sign chart, but that's getting pretty messy at this point. So you might just create a nice fresh one. And because you want all the numbers from negative infinity to negative 1, that would look like this, round parentheses, so we don't include the negative 1. We do include the 3, so we'll put a bracket there. We don't include the 5, and then that interval right there. So I hope that was pretty cool. Now I want to do one more example, and this one's going to require a little bit more work because you don't automatically have a 0 on one side of the equation. First thing, inequality, sorry. First thing you need to do is get a 0 on one side of the inequality. Well, that's not too hard to see what to do. We're just going to subtract a 2. Now let's look all the way back and see what step 2 said. Step 2 said I'm supposed to get one simplified and factored fraction on the non-zero side. That's going to be a little bit more work this time. I have two expressions. I need to create one fraction out of that. Well, the 2 is not even a fraction at all. However, you could write it as a fraction by just saying 2 over 1. But that's still 2 fractions. You could find a common denominator. The common denominator would just be x minus 7 if you took this fraction and multiplied numerator and denominator by x minus 7. You'd have a common denominator and you could combine them. This is now going to be greater than or equal to 0. Because the denominators are the same now, the 1 times anything is itself, you can copy the denominator, and because it's subtraction, subtract the numerators, 5x minus 2 minus 2 times x minus 7, greater than or equal to 0. I'll make a little bit more space over here. I think I can squeeze it in. I have to simplify a little bit because it does say a simplified fraction. Take this 2 and use the distributive law and multiply it out. You would then have 5x minus 2 minus 2x. Minus 2 times negative 7 would make a positive 14. X minus 7 in the bottom, denominator greater than or equal to 0. Remember, we needed that 0 on one side. Got some like terms to combine. Looks like we would have 3x plus 12 over x minus 7. We're going to need this result later on when we look at our sign chart and decide what we want to do with it. Okay. The next step, step 3, we set each of these factors greater than 0. So 3x plus 12 greater than 0. And I already forgot what the other one was. X minus 7 greater than 0. Not hard to solve either one of these. For the first one, we could subtract 12 from both sides and then divide by 3. X is greater than negative 4. And the other one simply would be x is greater than 7. Now these are the factors that I'm going to have in my sign chart. So let's start our sign chart with these 2 factors. And draw a number line underneath. And you may remember this from the first video. I can make a number line that has all the nice numbers between negative 4 and 7. All that really matters is that you know where those numbers are and that they're in the right order. So if you want to save yourself a little bit of time, on your number line, just put a mark here for negative 4 and a mark over here for positive 7. And you'll understand that you're looking at all the numbers in between. Now, we're concerned with the fraction 3x plus 12 over x minus 7. And we're going to use the work we have up here at the top of the page to figure out where to put our plus and minus signs. So this work here is showing me that 3x plus 12 is greater than 0, positive, whenever x is to the right of negative 4. So by the 3x plus 12, put a bunch of positive signs, plus signs, for all the numbers that are to the right of negative 4. And by contrast then, to the left of negative 4, you'd have to have negative signs. At negative 4, you would have a 0. Now, x minus 7 is greater than 0 when x is greater than 7. So x minus 7 is positive to the right of 7. Put a bunch of plus signs to the right of 7, and consequently a bunch of negative signs to the left of 7, and right at 7 you would have a 0. Now below the number line, we'll consider what happens to the fraction. And we'll look one interval at a time. You'll see here that to the left of negative 4, you'll have a negative number divided by a negative number. which results in a positive number. You pay really close attention to the values that give you a 0 and where those zeros are going to be. Notice that this 0 is a value for 3x plus 12. That's on the top. That's in the numerator. 0 divided by something is fine. 0 divided by a negative number in this case, that would give me a 0. So that gives me a quotient of a 0. Now I look between negative 4 and 7, and I see I have a positive divided by a negative, and that will make a negative. So I put some little minus signs until I get to the next 0. And I notice that this time my 0 would be in the denominator, and that's undefined. So that's really, really, really important to recognize. That will be undefined. I'll just put a U here. I used to draw a little skull and crossbones for that, but I'm not good enough with the Apple pencil to do that, so we'll just put a U. To the right of 7, we have a positive number divided by a positive number. Positive divided by positive is positive. There's my sign chart. Okay, well, so what? Well, we do have to remember what my inequality was at the end of step 2. That's this point right here where I did manage to get a 0 on one side and one simplified fraction on the other side. Notice that what you have is my fraction greater than or equal to 0. What that means in my sign chart is I want to pick all the places where I either get a 0 or a positive number because it was greater than or equal to 0. So, writing that in interval notation, we see that we would have positive values from negative infinity to negative 4. Negative 4 is a good place because that gives me a 0, and we wanted it to be greater than or equal to 0, so include the negative 4. Don't include the numbers between negative 4 and 7. Those gave me negatives. But then, from 7 on to infinity is positive. The only problem is you can't use 7 itself because that did not give you a quotient of 0. That led to something undefined. So you cannot use the 7, put a round parentheses on to infinity. And there you have it. That is how you solve a rational inequality. Since I have a minute or two left, I want to answer a question that you may not have stated, but you might be wondering, isn't this too hard? Let's look at the exact inequality we just solved one more time. And I want to ask you if you considered whether you could do something simpler. You might have thought, you know what? Oh, that's too much work. I remember that it's always legal to multiply both sides of things by the same thing. So what would happen if I took this and simply multiplied both sides by x minus 7 that should be legal. And that would be cool because on the left side, the x minus 7s would divide out, and I'd have this most simple inequality. 5x minus 2 is greater than or equal to 2x minus 14. And oh, that would be so easy because then you could just gather the x terms together. So you would say something like this. 5x minus 2x, subtract the 2x to the left side. Might as well, while we're at it, add 2 to both sides. We get 3x is greater than or equal to negative 12. Divide both sides by 3. X greater than or equal to negative 4. Done. Isn't that easier? Now there's a problem. That's not the answer I got before. So why doesn't this work? Well, it all comes down to this. Do you remember that when you multiply both sides of an inequality by a positive number, the inequality stays the way it is. But when you multiply both sides by a negative number, you turn the inequality around. Now, when I look at this inequality, when I begin, I don't know what values of x make this true and which ones make it false. It could be that the value that makes this true would give me a negative number in the denominator. If it gives me a negative, I would have to turn the inequality around when I multiply. But it might also be a positive number, and I don't know which. So the problem is this lovely looking thing that I did right here, where I multiplied both sides by x minus 7, is a big problem because I don't know if I'm multiplying by a positive number or a negative number, and therefore I don't know whether I should take this inequality and leave it the way it is or switch it around. The moral of the story is this: never multiply both sides of an inequality by an expression containing a variable. You don't know whether you're multiplying by a positive or a negative, and therefore you don't know whether you should turn the inequality around. So what do? You just do these steps that we saw, step 1, step 2, step 3, step 4, step 5, and that will always work. So I hope this lesson was helpful, and I wish you all the best.